So in this video, we're going to talk about buffering the inputs and outputs of the PLC, why it's necessary, and how to do it. So why is this a concern? The big idea is that we never know precisely where or it's very difficult to know precisely where in the ladder logic your PLC is executing at any particular instance in time. It loops through those rungs very, very quickly, possibly on the order of a couple of milliseconds. And so it could literally be anywhere at any given instance. And so if in your code, possibly without realizing it, you are altering an output more than once, and possibly because maybe it's intentional, maybe it's not, but you might not realize that you're altering an output more than once. And so this could cause an output to go to an inconsistent state. One example of what this would look like would be an output flickering, and I'll have an example video of that in just a minute. And so what we do and what is considered best practice to avoid this problem is that in the top rung of your ladder logic, you're going to always have a jump to subroutine, or JSR, that goes to a subroutine that buffers the inputs. So we're going to read all of the inputs in rung 0, the very top rung. Then we're going to do all of our logic in the middle. And then in the very bottom rung, we're going to jump to a different subroutine that takes our output tags and writes them to the physical outputs. So top rung, and I have this graphically here. So in this subroutine, we're going to take all the physical inputs and write them to tags. We're going to then use those tags for our logic in the middle. We're going to write them to output tags. Yes, there's a duplicate destructive bit here. We'll talk about that in a minute. And then in the last rung, we're going to go in here and take our output tags and write them to the physical outputs. So I'm now going to demonstrate both flickering and my solution. So this is going to serve as the before video, the kind of motivational video. If you look too closely at this code, it has a problem. It has two problems, and we're going to solve one of them, kind of. So part of what I want, so one, I want you to watch this light up here. So the problem is that both of these switches are trying to control this output, which is, if I click on this little button here that says verify routine, it'll tell me there's a warning. And my warning is that I have a duplicate destructive bit, which we'll talk about later in our course. And duplicate destructive bits, or DDBs, are bad practice in PLCs. But that's not the main reason we're looking at this right now. So this flickering should be a little bit concerning to us. And part of what I want you to hear is that when I'm executing a ladder logic program on my PLC, it's just constantly going through all of the rungs pretty quickly, sometimes 2 to 4 milliseconds, sometimes maybe 40 or 100 milliseconds, but it's doing a lot. It's just constantly looping through. And so I don't always know where in the code I am. And it's possible that sometimes it'll hang up on one rung or another, that kind of thing. And so we're seeing this flickering because occasionally this one wins, but most of the time this one is winning. And so what I want this to, so one, just duplicate destructive bits are bad. That's true. But the main thing I want you to take away from this as our motivational video is we're going to learn the practice of reading all of our inputs in our top rung and then writing all of our outputs in the bottom rung. And that way, if there's any kind of conflicting things that happen in the middle, they get resolved before we output them. And so what we're going to have you do in this lab activity that's coming up is to buffer the inputs and then buffer the outputs. And that way, anything that goes on in between works itself out, and I don't have conflicting cases that end up being really hard to debug. So in this video, I want to demonstrate how to create a new subroutine so that we can buffer our inputs and outputs so that we can solve the flickering problem that we have been dealing with. No, it's not going to flicker because I'm recording. Because I just did it. There we go. So that's the flickering problem. We're trying to get rid of it. Let's talk about how we're going to do that. So the first thing I need to do is add a new routine. I'm going to call the first one buffer inputs. And I wonder if I can just, can I copy this and go over here and paste it? Sure. So I'm going to take local 1 input data 0, and I'm going to write that to a tag. And my tag will be called PB0. PB for push button 0. It's going to be mad at me because PB0 doesn't exist, so I'm going to right click, create new Boolean value PB0. And then similarly, I'm not an expert in how to, okay. So we're going to create a new rung. We're going to copy this and paste it here, and then change it to local 1 in data 1. We're going to grab a new OTE. We're going to define a new tag PB1. Again, it's a bool, create. So I now have this input buffering that reads my first 2 inputs and writes them to 2 tags that I have defined. So what I now need to do is add a new rung, and I need to find the jump to subroutine program control, JSR. That's what I'm talking about. And then I'm going to come over here and I'm going to say, whoops, if I could type, buffer inputs should auto-complete. Input parameters are none. Not sure how to do that. I will have to Google that. Oh, it's happy now. Okay. That's weird. I'm not entirely sure what I did. And then, for now, I'm going to delete my other rungs. And then I'm going to add another rung. And I'm going to come over here and I'm going to add another routine that I will call buffer outputs. And in that routine, I'm going to read PB. No, wait a minute. If I'm really trying to demonstrate this to you, this would be PL0. So PL for pilot light. That's the semi-official name of the lights behind the push buttons. And I'm going to write that to local 2 out data 0. And I really would love to duplicate that rung. No, it's got to be possible, but I just don't know how to do it. That's okay. And then this will become PL1, which I will then right click and define as a bool, and then I will change this one, there we go, to local 2 out data 1. And so if I go back to my main routine and I add another program control JSR and my routine, let's see if I can understand this time how I did this. If I do that and I double click on it and then I click away, whoops, that is not what I wanted. Sorry, a little comedy of errors here this morning, which if you remember Shakespeare from high school, they're not actually funny. So how did I remove instruction parameter, remove instruction parameter, remove instruction parameter? Okay, so right now what I've got are 2, so I'm buffering my inputs, I'm buffering my outputs, but my inputs and outputs are not connected. So what I wanted to show by way of bad practice is that we can eliminate the flicker we were seeing before. Go back to favorites. I'm going to get two different XIOs. And I'm going to take both of those. And so this is, again, the bad practice that is the duplicate destructive bit, but it's to show that we've solved the flickering in a different way. So I'm going to write pilot light 0 twice, which admittedly, again, is bad practice. But I want to show that we've solved the flickering problem because we buffer before and after we do this thing. So if I came up here and I said verify routine, it tells me I've got a warning, I've got a duplicate destructive bit. Again, we'll take care of that later in the course. But I just want to show that by buffering my inputs, buffering my outputs, and then having my logic in the middle, I have solved the flickering problem. So let's get our document camera back up. Maybe it'll flicker once or twice while we're doing this. But once we have the buffering in place, there should be no more flicker. So what I want you to see, and I guess in theory I would have to have this thing here for an infinite amount of time for you to truly believe me. You should never trust authority figures of any kind. I'm very suspect. But now, PB0 is writing to this tag, and PB1 is writing to this tag, and this one is saying true, and this one is saying false, but we're not writing the output until we get to the end of the routine. So this problem has resolved itself, and PL0 is always false, and so you can see that this is off. And then let me do that just so you can see. So even now, even though PB0 is false, PL0 is still true. I'd have to think about buffering and why that's the case. But the light is always on. And if PB1 is off, then the light is always off no matter what I do. So we buffered the inputs, we buffered the outputs, we do the logic in the middle, and then if we accidentally contradict ourselves somewhere in the middle, our outputs are not indeterminate and giving us weird results. Hopefully that's helpful. We will, as a general rule, expect you to buffer inputs and outputs in all of the labs because it is considered best practice and it's going to make debugging easier. Thanks.